Okay, so maybe a little bit about the kind of exam that we will have. This is the mock test that I talked about. So maybe I wasn't sure yet, but I think the test would look something like this. Like sometimes maybe I will ask about properties, and you have to kind of tick true or false. Like today we will learn about KNN, LDA, and QDA, which used to be part of the exam in last year. And like this one is logistic regression. Like maybe I'll provide some kind of table that give you like a number of maybe properties. I believe you may be knowing like this one is p-score, this one p-score, p-value, yeah, and there's standard error and the value of coefficient, something like that. So maybe it is like, I'm not sure yet that, I'm not sure whether or not our exam would look like this, but this would just give you an idea like of what it might look like. Like previously there was just a table of one input feature, like what we learned last week. But this time, okay, maybe you would consider more than just one input features. You can consider like multiple input features, and maybe the question would be asking you to look at the coefficient, or maybe asking you to look at the p-value and provide your analysis as to, let's say in this example, you could probably tell that x2 is very important because p-value is closest to 0 and the coefficient value is very high. Like the second most important could be maybe this one or this one. But yeah, this is something like we have to analyze further as to what is more important, because if we look at the p-value, this one is actually lower than that one. Stuff like that. So but anyway, yeah, I think this one is p-value, I think, yeah. But anyway, this is just to give you an example of what the question might look like. Or like this one. This is like a bunches of questions that you can provide an answer based on looking at this regression analysis, where you have like the coefficient. Like for the first question would be, is whether or not loan amount has positive relationship with the loan status, which you can look at the coefficient. If the coefficient is positive, then it is yes. Yeah, it's true. Something like that. So yes, you can actually look at them. More than that could be something like looking at the confusion matrix, or maybe correlation. I think this one is correlation matrix, not confusion yet. But yeah, some of that would ask you to provide the confusion matrix, and I'm not sure if it's in here. Okay, may not be in here, but yeah, maybe the question would be like, maybe sometime I may provide the confusion matrix and ask you to compute F1 score. Usually it's multi-class examples. I mean, you can look at that. And this one is like QDA and LDA. Which one is LDA? Which one is QDA? If you look at the boundary decision, but you will get the answer like today, because today I will give you like overview of these algorithms. But yes, before first, we will go over like the discussion of k-nearest neighbor first, and then we'll go over. Okay. I cannot, for some reason, there's some problem with that. Let me check. What was that? I think there's some problem with the aspect ratio. I'm not sure why it was like that. I'm not sure why it was kind of like that. I think I haven't adjusted anything that was particularly weird. Alright, maybe this is like the best we can for the time being. Okay. Alright, maybe I have to do like a different mode. Let me check if that helps. Not helping. Okay, same mode is fine, but look like I have to scroll over. So if you cannot see, please let me know. Alright. So for the k-nearest neighbor, actually k-nearest neighbor is probably one of the simplest types of the learning algorithm, because I'll redraw the picture, because it doesn't really need a training phase. So sometimes we will call it a lazy learner. Okay, sometimes we call it a lazy learner. And we'll come to that why we call it like that. But yeah, just to give you a heads up, it doesn't need a training phase. What does it mean is that it doesn't require you to learn model parameters. So if you remember last time, if we have to learn for like okay, it come back to normal now. Okay, if you remember last time that we learned about that if we have like a training phase, right? Usually being that if we have beta is equal to argmin, maybe something like y minus ax, okay, x beta, something like that. Something like this. And you have to solve for beta. This means that you need a training phase where you have to learn model parameters. But k-nearest neighbor will be the one that does not need this at all. But what it needs are, firstly, it still needs training data. And that training data has to come with label. So it's just the training data that we have been using in our previous topics, like if we learn for logistic regression, neural network, all of that, and or maybe if you think about the regression, linear regression, we still need like both input features and the target. For k-nearest neighbor, which is similar to those classifiers, the target will be the label, like class label. So need label as target because it's doing the classification task. Okay, so what is it if it kind of have this configuration as like a machine learning algorithm? So okay, maybe I should describe how it works. Okay, firstly, let's say if we have training samples, right, and its associated label. Training input samples, like we have X input features and its associated label, that is Y. So let's say if our X is like two-dimensional, so you can write it as like X1, X2, and then maybe you use the X and Y axes to represent the value of X1 and X2, and then you do like a scatter plotting. You probably get something like the red dot here. Maybe there are like the data point, the xj point, that whose associated yj is in the class A or maybe class red. And for these, maybe there are xj and yj, where yj is belonging to the class B or maybe the green value. So it's just like if you have the training data, you can definitely plot this, like provide this plotting where you have like the value of X and you highlight those data samples based on the class that it belongs to. So yes, you can have these plots. And what k-nearest neighbor does is that it exploits this fact that if we have training samples with labels, definitely we can, like throw a testing point. When I said it's a testing point, simply mean that this point is like does not belong to the training sample. So it's the testing data that maybe we have only X. Okay, we definitely have only like the input feature. When we have this testing data, we can then calculate the distance between this testing data with the training data around it. So let's say you may start to be able to calculate the distance between this yellow point, which is testing, versus those red points, which are in training, but we know it's like the points that belong to like the class A or a red class. And you can also do the calculation like of the distance between this yellow point and class B or the green classes. After that, you can measure the distance, right, between this yellow versus all these points. And then you can judge whether or not this testing data should belong to class A or class B by doing something like a majority vote. But if you want to use all the samples right around it, right, it will be like which class have more samples will identify that point as the same. For example, if we have more data points belong to class B, very likely this one will be generalized as class B. But if we scope our neighborhood area down, let's say to just one, definitely the closest to it is like class A, right? So you can see that if our area of neighborhoods that we say the radius here, if we use a very small neighbors, the smallest is like just one neighbor to judge, we can make a mistakes if these points may be having some kind of noises because it judged based on the feature distance between this testing point and the point that are closest to it. But if we relax a little bit, let's say we use maybe 3 data points, and from this we probably see that these 3 are the closest. With the majority vote, you probably have the class B. Yeah. And yes, the performance of this k-nearest neighbor classifier will depend on the size of the neighborhoods that you want to consider. And the size of neighborhood in this case is going to be defined by the number of neighbors or the number of nearest neighbor. So that will be your criteria for like how you would judge that this belong to which class. And let's go back to that previous example where I said that what if we use all the data samples as being the neighbors? Problem is, if you have more samples that belong to class B, then your judgment will be biased by the number of samples in your training. So that may not be something you want. So yes, we want to adjust this number to be the one that is most appropriate. And in this case, that's okay. And in this case, we normally judge this number by running the validation. So we will run this algorithm on the validation set. And we'll pick the number of nearest neighbor. Maybe I'll just abbreviate it as an N. This number of nearest neighbor to the one with the lowest, maybe the lowest error on validation set. So that's pretty much it about the k nearest neighbor. In fact, if we think about it, number of nearest neighbors is one of the parameters. Actually, there's another hidden parameters here that is how you calculate the distance. Like generally, you may want to use just normal Euclidean distance. But you can change it from, let's say, the L2 norm to L1 norm, whatever norm that you want to calculate distance, that could be another hyperparameters. So you can choose those based on your result on validation as well. Yes. So that is k nearest neighbor. What else? Okay, let's go back a little bit to, let's say if we have the number of nearest neighbor to maybe 5, maybe that will end up with this selection. And then when we judge that it belongs to this green group, you can either do the majority vote, but don't forget that when we do the majority vote, it's like you have to count, right? So how would you efficiently compute this counting operation? One way you may be averaging, let's say not averaging, but it's like calculating how many samples from class B are being included in the neighbors. Let's say for this, you will have like the probability that this X belong to green, I would use this way, as a sum of all the Y that is in training that was in the class B. Let's say if this is like a neighbor, I equal to 1 to k. Let's say, let me use k as a number of neighbors, right? So that's divided by k. So that will look like a probability of how many, like the chance that this X should belong to this rectangular class B. Maybe I'll do it. Or if you want to calculate the probability of being in class A, you may want to do something like and in this case, if more of the samples within your neighbors are in class B, definitely you will have more, like higher value of P of B given X larger than P of A given X. So yes, when we do the counting like this is like, it's equivalent form where it is similar, it's as if we were computing the conditional probability of being to one class given our input sample. So that is the information that was written here. That is it, I think. Yes, so actually this is these are the steps that if you were to write it like in a proper way, I mean, I actually already described it here. And yes, this is like when belong to class A or class B, that's kind of like another explanation that I gave in the morning. But yes, it's the same result. One more thing that I would like to like capture, that is the effect of having small number of neighbors or large number of neighbors. So of course, if our neighbors is very small, it tend to have this very delicate decision. Like if it's close to someone, it will just pick that one. If K is large, like hundreds, the decision will be smoothed out a lot compared to that, right? But if K is somewhere like 10, maybe you get the best result from here, but it depends on your validation result. This is just to show you what it's like. So that's it for the K nearest neighbor. Yeah. And the details, you can find it in here. There's a little bit about a bias variance. If you look at the result, when K is small, right, like equal to 1, you have a very delicate decision. And when it's very delicate, it's described to be highly flexible in a way, right? So that will introduce high variance if K is small. But if K is large, then your decision will be biased by the number of training samples. Then, so when K is large, then it has high bias. So another note is like small K, high variance. Large K, high bias. So this is something that you may be thinking about if you encounter something. Like if the performance is not good enough and you feel like you want to increase the bias or you want to increase the variance, maybe you can adjust from choosing this size of K. Yeah, that's it for this topic. Okay. Yep, that's it.